So when you try to integrate a fraction where the denominator is factorized, normally we would try splitting this into partial fractions. So we'd have a over x plus 1 plus b over x minus 2. And then you'd find a and b, and then you'd have two luns. In this case, it is worthwhile checking whether you can factorize the numerator to see if you're able to cancel one of the factors in the denominator. It's pretty clear that you can in this case. So before you rush into doing the partial fractions, if you look at the numerator, there's clearly a 2 that's common. So you can rewrite the question like that. And now we have these terms which clearly cancel. So now we have a much easier integration. We've got the integration from 4 to 5 of 2 over x plus 1. And here we don't need partial fractions because, remember, the standard integral of 1 over x dx is simply the natural logarithm of the modulus of x. So using that, we are able to integrate this simply by saying the answer is 2 times ln x plus 1. I'm not going to say plus c because we have these limits. So it's a definite integral. We just need to add these limits here, and then we substitute each of these limits. We substitute the 5, we substitute the 4, and we subtract. So the answer will be 2 ln 5 plus 1 minus 2 ln 4 plus 1, which is 2 ln 6 minus 2 ln 5. And you can leave it like that if you like. You could say that that's ln, 36 over 25, if you like. I think that looks nicer, but that's perfectly fine. So that's how you would find the exact value. Obviously, you can put that in your calculator and find it to any number of significant figures as required. So the point here really is that even when you have a fraction that you can split into partial fractions, it makes sense to see if you can first factorize it. Because if you're able to cancel one of the terms from the denominator, it makes life much easier. It saves you having to discover that one of your constants is actually 0. So I hope you found that helpful.